Right, so you may have been extremely impressed by me or Mr. Rattigan or whoever your teacher is being able to do sine and cos and tan of angles really quickly, seemingly in their head, and you might have wondered how on earth did they know that. So what we're going to talk about now is how you can, sorry, I'll rephrase that. We're going to talk about the angles that you need to know the exact trigonometric ratios for. Okay, there's the word exact. Exact should conjure up things like square roots or leaving pi in your calculation, and it's going to be square roots that are important here. So the first one we're going to deal with is an equilateral triangle. Okay, we know that an equilateral triangle has angles of 60 degrees in all of the angles. Let's have an equilateral triangle with side lengths 2. Excuse me. Now, if we drop a angle bisector down from that top angle to make 90 degrees there, we create a 30 degree angle there. Okay, so we've got 60, 30, 90. And it's the 30 and the 60 degrees that we're going to focus on. Now, before we go looking at trigonometric ratios, we're going to figure out what is the height of this angle bisector that we've made. Okay, so if we deal with that in isolation, we've just got a right angle triangle that's 2 on the hypotenuse. Because we've bisected this side, it's 1 there. So using Pythagoras' theorem, you can get that that's the square root of 3. Okay, so we can write on that height that it's the square root of 3. Okay, and so now that we've got those angles, we can start thinking about what sine of 30 is. Sorry, now that we've got those side lengths. Okay, we can look at sine 30, and we know that sine 30 is opposite over hypotenuse, so rather than putting 2 there, why don't we put it as 1 and 1? Make it simpler. So sine 30, opposite over hypotenuse is a half. Okay, opposite over hypotenuse. And we can do that for all the other ratios. So you can do it for cos 30. Cos 30 is adjacent over hypotenuse. So the adjacent side is the square root of 3. The hypotenuse is 2. Okay, so that's adjacent over hypotenuse if we're considering the 30 degree angle. Tan 30, hopefully you can see where this is going now. That's opposite over adjacent, so that's 1 over root 3, and you'll remember from earlier on in CE1 that it's good practice to rationalise denominators like that, so we can write that as root 3 over 3. Okay, we can do exactly the same thing for the 60 degree angle as well. So we can say that sine 60 is opposite over hypotenuse, so sine 60, I'll tell you what, that's going to be unclear, so why don't we give it a bit more space down here. So sine 60, that's opposite over hypotenuse, so that's root 3 over 2, opposite over hypotenuse. Cos 60 is adjacent over hypotenuse, so we get a half, and tan 60 is opposite over adjacent is root 3. Okay, so all of those 1, 2, 3, 4, 5, 6 different ratios you need to know off by heart. So if someone says to you sine 60, you know that that's root 3 over 2. Sine 30 is a half, particularly when you do mechanics next year, because they very often use these sorts of angles. So it's helpful if you've got a really good memory of them. You know, you can just bring them to hand really quickly. Okay, so that's the first lot. There is another set of exact ratios that we need to know about that come from a different triangle, not from the equilateral triangle. So that's the first lot. Now if we draw a second triangle, this time we're going to draw an isosceles right angle triangle that's side length 1, and side length is square root of 2. You get that from Pythagoras if you're you're not sure. Because it's an isosceles triangle, these two angles must be the same, and they must add up to 90. So they're both 45. Okay, so we're now going to come up with exact ratios for angles of 45. So if we start with sine 45, we've got opposite over hypotenuse. Rationalising the denominator, gives root 2 over 2. You'll spot that cos 45 is exactly the same. But that tan 45 is slightly different, so opposite over adjacent, tan 45 is just 1. Okay, which makes sense. So they're the second lot of trig ratios that you need to remember. You need to remember all 9 of those. Okay, or at the very least, remember that some of them come from that triangle and some of them come from an equilateral triangle. Okay, I think that's about all there is to say about that. Thank you.